Hello everybody, and welcome to part 2 of the physics review. Today we'll be working on 2D motion. Let's take a look at our question. A basketball player who is 2 meters tall is standing on the floor with a length of 12 meters from the basket. If he shoots a ball at a 33-degree angle with a horizontal, at what initial speed must he throw so that it goes through the hoop without striking the backboard? The basket height is 3.05 meters. Really quickly, I just like to sketch another picture, this time including the length of the floor and also adding a coordinate axis in so that we're able to see which directions we're calling positive. After that, I like to draw a givens chart. So we look at change in position, we look at the initial velocity, the final velocity, the acceleration, and the time. In our chart, it looks like there's a lot of unknowns, but we can fill some of these in quickly with the information they gave us. Let's start by drawing a vector diagram. V naught is the vector, and V naught x, which is in the x direction, and V naught y are our vector components. So we're going to use trig to find the x direction, so the V naught in the initial velocity in the x direction, and the initial velocity in the y. So as you can see here, for initial velocity in the x direction, it's V naught equals cosine of 33 degrees. And for the initial velocity in the y, it's V naught equals sine, initial velocity is V naught sine 33 degrees. But we can also fill one more thing in. Since we're in the x direction and there's no other forces acting on the object in the x direction, the x has a constant velocity. So final velocity will also be cosine of 33 degrees. Next, we're going to try and solve for time. So we have the most information and what looks like the easiest in the x direction. So we're going to start by plugging that into the kinematic of change in position equals initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. So we know the change in position is 12. We can fill in the initial velocity with V naught cosine 33 times time plus 1/2 of 0 multiplied by time squared because the acceleration is 0. So that whole cancels out. So now we have 12 equals V naught cosine 33t. And what we're left with is time is equal to 12 over V naught cosine 33. But what do we do with this number? Well, we're going to substitute it in for when we go into our equation in the y direction. So now we have change in y equals the initial y velocity times time plus 1/2 acceleration times time squared. We can fill in the change in position. We can fill in the initial velocity. We can plug in our equation that we found from over here into time plus 1/2 the acceleration of negative 9.8 because it's falling downwards and it's in free fall times, once again, our substituted time for 12 over V naught cosine 33. From there, we can cross out V naught from this two because they will be divided out. So then you get 1.05 still equals 6.533 after you solve for this, multiply these two, then divide it by cosine 33, plus 1/2 of negative 9.8 times 12 over V naught cosine 33 squared. Next step is, again, this stays the same, equals 6.53 minus 4.9, so I have a 9.8, times 144, so 12 squared, over V naught squared times cosine 33 squared. So we're going to do, for our next step, we're going to multiply this by the numerator and then divide by this so that we only have V naught squared left in the denominator. And this is what that's going to look like. So then on to our next step, we subtract 6.53, you get negative 5.48 equals negative 869.2 over v naught squared. From there, it's just doing the algebra, multiply v naught squared by both sides, divide by negative 5.48, then take the square root to get v naught equals 12.2 in the y direction. So now we have 12.2 in the y direction. So our answer to the problem is going to be 12.2 meters per second. But let's take it a little farther conceptually by looking at a position time graph in the x direction. So overall, we know the object is going to travel 12 meters, but how do we find this time down here? Well, we're going to take our equation, 12 over v naught cosine 33, and we're going to plug in our now new information that we solved for of 12.2 to get a time of about 1.2, 1.1 seconds. And we can reason this out because if it's 12 meters away and it's traveling about 12.2 meters per second, we know it should only take about a second to get there. So that's how we can test our answer and take a look at it in a conceptual light. I hope you learned a lot from this problem. Overall, the main thing that I learned was substituting, for example, how we substituted the time from the x into the y. Overall, it helps me be more resourceful and helps me look for more specific details and where I can plug things in. Thank you.